Prove that the sum of any two odd integers is an even integer. Now, if you ever ask, we don't have this in the IGCSE, it's in the GCSE. If you ever asked about sort of any odd number, any even number, you can define those in a certain way. If you just think about what the even numbers look like, so the even numbers look like this: 2, 4, 6, 8, 10, 12, and so on, right? And if you know a little bit about sequences, you know that the nth term of this could be, well, it is plus 2 plus 2 plus 2, which means it's got a 2n, and it's just 2n, right? So if you're asked for sort of any even integer, you might call it 2n or 2k or 2 something, where the something is an integer. If it's asking about any odd number, if you think about the odd numbers, 1, 3, 5, 7, 9, 11 and so on, think about the nth term of the odd numbers, well, it's still a 2n. So it's still 2n, but it's 2n minus 1 in this case. So if you had an integer n, for whatever n was, as long as it was an integer, if you times it by 2 and take away 1, it would give you an odd number. So if you're asked for any odd number, you can use maybe 2n minus 1, where n's integer, 2k minus 1, or you could even say, well, what about 2k plus 1? That would also give you an odd integer, because if you think from minus 1 to plus 1, it skips 2, which is what you need to do to get from one odd number to the next. If you asked about kind of two consecutive even numbers, you might try 2n and then 2n plus 2. And these, if you asked about 3 consecutive odd integers, you might say this, and then the next one would be plus 3, and so on. So if we need any 2 odd integers, so we're going to need 2 numbers that could potentially be different. So we are going to define our 2 odd integers are going to be, we'll call them m and n. They're going to be our odd integers, and we're going to say let m be some 2r plus 1 for integer r. R must be an integer. And so we need to define n using a different letter. We'll just use s. So let n be 2s plus 1. 2s plus 1 for integer s. Right, so then that would mean that m plus n, i.e. the sum of the 2 odd numbers, would be, well, m we said was 2r plus 1, plus n was 2s plus 1. So that is going to be 2r plus 2s plus 1 is 2. If we pull a 2 out of that, the way you show things are even is you show that it's 2 times an integer. And because if you get any integer at all, times it by 2, you will be left with an even number. But that's what the even numbers are, really. There's some numbers that have been times by 2. So this must be 2 r plus s plus 1. So we knew that r is an integer. We know that s is an integer because we defined it to be so. We've written it there and there. 1's obviously an integer, so this is 2 times integer, which must be even. So that is our proof. So if we just finish it, therefore the sum of any 2 odd numbers is an even number, or is even. Is even.